Today, we are going to crack the code on one of the most exciting and, frankly, frustrating challenges in AI art. We're talking about how to look at any piece of digital art and figure out the exact text prompt that created it. Let's get right into it. You know the feeling, right? You're scrolling through your feed and you see this absolutely stunning, hyper-realistic image. And you just think, wow, I have to make something like that. You've got the image right there, you have the idea, but getting the AI to actually replicate it, it feels like it's pretty much impossible. So what do? You start guessing. You type in things like, futuristic engineer in a lab, maybe glowing blue lights, cool computer. But the thing you get back, it's just a mess. A distorted, kind of weird-looking image that is nothing like the masterpiece you were looking at. This is that frustrating guessing game that we've all been playing with AI. And let's be honest, it's a game we almost always lose. But what if you could just stop guessing and start engineering? That's what we're going to cover. First, we'll talk about that AI guessing game and why our best descriptions always seem to fail. Then, we'll get into the huge difference between a description and a real prompt. We'll look at how AI finally learned to see, and then I'll share the secret meta prompt formula that basically forces an AI like Gemini to tell you exactly how an image was made. From there, we'll unlock the artist's code and look at the real-world impact of all this, which is massive. Okay, so first things first, let's really break down the core problem. Why does this guessing game feel so completely rigged against us? Well, the answer is all about how these AI models actually, well, think. I'm sure these pain points look pretty familiar. The image you get looks nothing like what you wanted. The AI just kind of hallucinates details, right? It adds things that just aren't there. And this is the big one. It completely fails to capture any of the technical stuff. You know, the specific camera angles, the exact kind of lighting, the rendering style. Our simple human descriptions, they just don't have the structured framework the AI desperately needs. And that brings us to maybe the single most important idea in this whole explainer. See, we've been trying to speak our language to the machine when what we really need to do is start speaking its language. And here it is. This is it. The fundamental reason why almost all of our attempts go wrong. A description is not a prompt. A description is what a human sees and says. A prompt is a set of technical instructions for a machine. They're two totally different things. What the AI actually needs is something called prompt syntax. Now, this isn't just a jumble of descriptive words. It's a hyper-specific technical vocabulary. Honestly, you should think of it like a programming language, but for images. It has the exact terms for camera lenses, for lighting models, for rendering engines, all the stuff the AI was originally trained on. You know, the source material gives us this great way to think about it. An AI's latent space, which is basically its giant internal memory of images, is like a huge library filled with concepts. Our job isn't to describe the outside of the library, it's to give the AI the exact precise call number so it can go find the right book on the right shelf. And this table just illustrates that difference perfectly. We might say, a futuristic engineer. That's our description. But the prompt syntax the AI needs specifies the style as a hyper-realistic Unreal Engine 5 render, the camera as a 70mm lens medium shot, and the lighting as volumetric lighting with glowing blue nodes. You see? It's a precise recipe, not just a casual observation. So how in the world did we get to a place where an AI can even pull these concepts out of an image? I mean, the ability for an AI to truly see is actually a very, very recent breakthrough. The progress here has been just incredibly fast. If you go back just to 2021, we had these basic tools that were, well, they were highly inaccurate. Then by 2023, models like GPT-4V came along and introduced a basic sense of spatial awareness, what objects were where in an image. But the real game changer is what's happening right now. A model like Gemini can natively process visual information as tokens, the same way it processes text. There's no translation layer needed, it just sees the image directly. And because it can see natively, we can use this really clever trick to get exactly what we want. This is the secret sauce right here, the meta prompt formula. We're not just going to ask the AI a question, we are going to teach it how to analyze the image for us. And it's this super simple but really elegant three-step process. First, you upload your reference image. Second, instead of asking it to just describe this, you inject what's called a meta prompt. This is basically a set of instructions that tells Gemini to act like a professional prompt engineer and break that image down into its core technical parts. And third, you just extract that perfectly structured, ready-to-use prompt syntax. So, what do you actually get at the end of all this? This is where it gets really cool.
We go from theory to practice and literally unlock the original artist's code. Look at this. Instead of some vague description, Gemini now hands us a precise, machine-readable parameter. The camera isn't just kind of zoomed in, it is a 70mm lens. That is something you can literally copy and paste directly into your own prompt.
And it's the same thing for lighting. It's not just glowing lights. The AI identifies the specific technique being used, volumetric lighting. This is a technical term that completely changes the mood of an image. And now you have the exact keyword you need to get it.
And finally, the style itself. The AI recognizes that the whole aesthetic is similar to an Unreal Engine 5 render. So by combining these extracted pieces, the camera, the lighting, the style, you can now replicate the soul of that original artwork with incredible accuracy. You've literally reverse engineered the recipe.
Now this is amazing for artists for sure, but the implications here, they go so much further. This whole technique of deconstructing an image into data is about to have a massive impact across a ton of different industries. Just think about it for a second. Game developers can now pull prompts for specific textures they want to create. Marketing agencies can finally ensure perfect visual consistency by reverse engineering their own brand assets. Any digital artist can find a lighting style they love in a photo and apply that exact style to their own work. I mean, this solves some huge workflow problems. Ultimately, what this all really means is that we've made this fundamental shift in how we create. We have officially moved on from the frustrating, random act of guessing what a prompt might be to the precise, repeatable process of actually engineering it. We've finally learned how to speak the machine's language. And that kind of leaves us with this one fascinating final thought to chew on. We've just seen how AI can deconstruct the how behind a piece of visual art. So the question is, what creative process is going to be deconstructed next? What's it going to mean when we can reverse engineer the formula for a hit song, or a compelling story, or maybe even a scientific breakthrough? The possibilities are absolutely staggering.